So I'd like to work through the solutions to the quiz 5 that you all just took. So question 1, you can read through it. I'll just summarize it quickly, that you're looking for a minimum sample size, wanting to be 99% confident within 16 calories. So for question 1, when it comes to minimum sample size, there's two different formulas that we want to use. One of them is a formula for sample or for means, and the other one is for proportions. You're not looking at proportions, you're looking at means here. So you're looking for this average. So the formula that you want to use is going to be n is equal to z sub alpha divided by 2 times sigma divided by our margin of error, quantity squared. So in this case, we have to find what is z sub alpha divided by 2. Well, because we are 99% confident, looking at the chart, you should get 2.576. Our sigma, in this case, is going to be 135. That is our population standard deviation, and our margin of error is 16. So once you plug all of this into the formula, you should get 2.576 times 135 divided by 16. That quantity is squared, and you get a 472.4 or something. Now, we're asking about the minimum sample size necessary. So to say the minimum sample size is 472.4, that doesn't make sense, right? How can you say that you have a sample size of 0.4, for instance, because these are people that you're trying to find. So our minimum sample size, we always have to round this number to a whole number because it makes sense, right? But we always have to round up. So our answer needs to be 473 because this right here, this is the absolute minimum. If we went down to 472, we don't have the minimum anymore. We have to always round up. So always round up. All right, so question number 2, now you're looking at a confidence interval, and so in this one, you're looking for a confidence interval. So you're looking for a confidence interval, and what you're looking at in particular is one for means, and the question, because there's 2 of them for means, do you know the population standard deviation? Well, in this one, we do not, because it says based on a sample of 9 years, blah, 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 the mean is 435.6 with a standard deviation of 56.8. That standard deviation is referring to the sample, not a population. So we have an unknown population standard deviation. So in this case, what we know is for instance, n is equal to 9. That is our sample size of 9 years. We have x bar. This is our mean from the sample is 435.6. We have our sample standard deviation is 56.8. Because we have an unknown population standard deviation, we have to find degrees of freedom, which is always n-1 for these, so we have 8. Now our t sub degrees of freedom, this is really t sub 8. So if you look on the chart, for the 95% confidence with the row for degrees of freedom being 8, you should find this to be 2.306. Many of you who got to this point did not find the correct number here. You ended up using t sub 9, so make sure that you use t sub 8. So the formula now for this confidence interval that we're looking at is it's going to be x bar minus t sub degrees of freedom, s divided by the square root of n, is less than mu, which is less than x bar plus t sub degrees of freedom times s divided by the square root of n. So now we plug in everything that we have over in this side. We just plug everything in there, and so our final answer should be 391.94 is less than mu, which is less than 479.26. So now we move on to question 3. This again is looking for a confidence interval. So we're looking for a confidence interval But in this case, we're looking at one for proportions. So the formula that we're going to be working with here is going to be P dash minus Z sub alpha divided by 2 square root of P dash Q dash divided by N is less than P, which is less than P dash plus Z sub alpha divided by 2 square root of P dash Q dash divided by N. Now, again, finding the information from this problem, we would see N is equal to 400. Our X in this case is 64. So this is the number of people that have the desired characteristic. So we use this to find P dash, which is going to be 64 over 400. So that is going to be 0.16. Our Q dash is always 1 minus P dash. So this is going to be 1 minus 0.16. Or in other words, this is 0.84. Our Z sub alpha divided by 2, because we're looking at 90% confidence, this is going to be 1.645. So now when we plug all of this in to this formula, we're going to get 0.13 is less than P, which is less than 0.19. So again, what we're talking about here is we're saying that we are 90% confidence that the true population parameter for proportions is going to be between 0.13 and 0.19. Now moving on to question 4 and question 5. This one says that the average American has about $10,000 in savings by the time they are 25 years old. We'd like to figure out, does a personal finance class increase that amount? So they gather information. They found that this average here is $14,567. So if we look at these two, what we have is that our X bar, this is our sample mean. Our sample mean is equal to 14567. So many of you answered questions that had this number in it. This is our sample mean. But we need to remember here that the hypotheses that we're stating, hypotheses talk about population parameters. So we will never, ever, ever have samples appear in there. So samples will never appear in our hypotheses. We always talk about these population parameters. So our null hypothesis is always going to have something about a population parameter, and in this case we're looking at means, which is mu. And many of you got the equals part right. But if nothing's different, so if these students who take, or if these people who take the personal finance class are the same as everyone else, that means the average is still going to be 10,000. So this is our null hypothesis. We basically say here that there is no difference. There's no difference with these people taking the course than with the average American. But the test we're trying to claim here, possibly, does this increase? Do these people save more than $10,000? And so both of these numbers have to refer to the fact that the population parameter is talking about 10,000. And so these were our two hypotheses. Again, making sure that you use mu, not X bar. So hopefully that helps. If you do have questions about any of these, please don't hesitate to ask me, and I'd be happy to talk to you about your specific answers from the quiz.